This is Algebra 1, Chapter 1, 1.5, which is page 30. Let's see here, page 28 in your book is where we're going to start. And I'm going to have you kind of skip ahead of just a little bit. I noticed that the vocabulary is formula, and I want you to write that down in your notes. But if you would just take a second and flip over to page 30. The top of page 30 has some key concept. It's got a key concept box. And above that, it says a formula is an equation that relates two or more quantities. So if you look at probably one of the most formulas that you're familiar with, area equals length times width. That shows a relationship between two quantities. It shows that if you find the product of the length of a rectangle and the width of a rectangle, you will end up with its area. So here's a few formulas I want you to write in your notes. We have a formula for temperature. Sorry, my pen again does not like to work. Temperature. Okay, and write that formula down. I'm not, because my pen is not working good, so you can write it down. Write the formula for simple interest. There's also a formula for distance traveled, and I'm just going to write distance if I can get that all out. And then there is a formula for profit. It's supposed to be an R. So go ahead and write those formulas down. We'll come back to those formulas. You can just have, that way you have them down, and we'll use them as we do some problem solving. So the name of this lesson is Use a Problem Solving Plan. So if we go back to page 28, I also want you in your notes somewhere, and it'll stay on this page. I'm just going to go over here if it'll let me. A problem solving plan. Here's the plan to solve problems. Number one, okay, you need to read it, and you need to understand. Okay, and what I do when I'm solving problems is I might just read it the first time and maybe not read it really slow, but just kind of skim through it. And then I slow down. I might read it out loud. I might try to pick out some important facts and different things about it. Number two, or what I might need to use to solve it, the trash part that I could throw away. Step two, I'm gonna make a plan, and that plan is going to be how am I going to carry out solving this problem. Number three, I'm going to solve it. Okay, and number four, I'm going to look back. And I'm going to look back and I'm going to say, I'm sorry, that's really bad to read. That says look back. I'm going to look back and I'm going to say, hey, does my answer make sense? Is it reasonable? And that's very important when you're solving problems. Don't just think because you got an answer that it's automatically right. You need to look back and say, hey, did I do that right? So let's take a look at an example. Here's reading a problem and making a plan. The problem is about running. It says you run in a city where the short blocks on the north and south streets are a tenth of a mile long. The long blocks on the east-west streets are 1/1500 mile long. You run 2 long blocks east, a number of short blocks south, 2 long blocks west, then back to your starting point. You want to run 2 miles. How many short blocks should you run? So I look back and I know, I'm going to say, okay, let's read. What do I know? I'm trying to understand it. I know that these are how long the long blocks are. That's how long the short blocks are. This is how long the long blocks are. Long is right there. There's the short block. So I know the distance of the blocks, and I know that I'm going to run 2 long blocks east and then 2 long blocks west. So I know how many long blocks. I'm going to run a total of 4 long blocks, but I don't know how many short blocks. So just kind of reading, trying to understand, figure out what I'm doing. So let's see how they kind of approach it. Read and understand. What do you know? And it's kind of what we just did. You know the length of each side of the block, the number of long blocks you're going to run. We also know our total distance was 2 miles. So we can conclude that you must run an even number of short blocks because you run the same number of short blocks in each direction. Because you ran so many blocks over, then you got to run that many blocks back. So what do you want to find out? We want to find out the number of short blocks we should run. So it says make a plan. It says, I think we should write out a verbal model, and we could draw a picture. There's all sorts of things you could do to solve this problem. So let's do that. They made a Verbal model, remember a verbal model is a model that uses words. This is a verbal model right here. It's using the words to solve it. And what we're going to do is we're going to put in what we know into that verbal model. And you'll see, okay, remember 1/10 was the length of a short block. This S, we don't know how many short blocks we need to go. 15/100 was the length of a long block. And we knew we went 4 long blocks. And then our total distance over here is 2. So that, let's see what happens here. There's our equation. We take all the stuff out of there now. So it says, this is a guess and check kind of thing. They say, so let's try 20. So they substitute 20 in for S. Look what happens right here. Get going. And 2.6 does not equal 2. So 20 is too many blocks. So they kind of, so let's try a lower number. So they try 14. So put in 14. And in that case, 14 worked out great. So it says we should run 14 long blocks with the 4 long blocks to make our 2 miles. So we look back and it says you run 6/10 of a mile in long blocks, because if you remember that we took 15/100 times 4 and got 6/10. And then each, check out, they made a little table. They're just going to start counting up by 2 here. We're at 6/10 because that's how much we ran total for the long blocks. Now let's add the short. Every 2 short blocks, we get to add 0.2. So there's 2, 4, 6, 8 short blocks, 10 short blocks, 12 short blocks. 14 short blocks gets us up to our 2 miles. So it's kind of nice visual to see the table right there. So then in our guided practice it says, suppose that you want to run a total distance of 3 miles. How many short blocks should you run? Now they didn't change the number of long blocks. So what's nice about this is we already know that we had to run 14 short blocks to make 2 miles. Okay, so every short block is 0.1. So if I run 10 more short blocks, 10/10 or 10 dimes, one way to think out of it, makes $1, would make that other mile. So 10 more blocks to that would be 24. Let's see how they looked at it. This is a good and bad about math. They get 24 blocks. They didn't give us a solving, but sometimes I always say the good thing about math is there's more than one way to solve things, and sometimes the bad thing about math is there's more than one way to solve things, because sometimes it's kind of confusing. We want sometimes to be shown just one way to do things. So don't limit yourself to one way. Sometimes one method is good for a certain situation and another method may be good for a different situation. So example number 3, we're doing the standardized test practice, which is this is going to involve a formula. You'll see it's on page 30. You're making a leather book cover. You need a rectangular piece of leather as shown. That's the dark brown around the outside here. That's the leather. Okay. Find the cost of the piece of leather if it's 25 cents per square inch. Now when I see per square inch, that right there is our cue, or our little thing to say, hey, we're looking for area. So that's a rectangle. So the area of a rectangle is length times width. The length of that piece is 18. The width of that piece is 11. So to find its area, that would be 18 times 11. So we get 8 and 1, placeholder 8 and a 1. Okay, there's 198 square inches right there. Now, every one of those square inches costs 25 cents. So it'd be like taking 198 times 25. So I get 0, carry the 4, 45, plus 4 is 49. 5 times 1 is 5, plus 4 is 9. Placeholder 16. 8 times 2 is 16, carry the 1. 2 times 9 is 18, plus 1 is 19, carry the 1. 2 times 1 is 2, plus 1 is 3. So I get 0, I think that's a 9. 15, carry the 1. 19, carry the 1. 4. And it's money. There's 2 decimal places up there, so I put 2 decimal places in down here. So I am going to say it's going to cost me $49.50 for my leather book cover. It's a good thing it's leather. That's pretty expensive, isn't it? So they do length times width, same thing we did. And they wrote the formula, they substituted the numbers in, multiplied, and then took that times 25 cents. So then the correct answer was B. So in our guided practice, let's talk about gardening. A gardener determines the cost of planting daffodil bulbs to be $2.40 per square foot. How much will it cost to plant daffodil bulbs in a rectangular garden that is 12 feet long and 5 feet wide? So my plan is following the same thing we just did. I'm going to make a little picture. It's 12 feet by 5 feet. So 12 times 5 for the area is 60. Notice they got 60 right there. They're trying to fool us. It's not 60. That's just how many square feet there are. And for every square feet, it costs $2.40. So 240 times 60. And let's see, we can really do 24 times 6. I'm going to take the zeros off. 4, carry the 2, that's going to be 12 through, that's going to be 144. Add the 2 zeros on, put in the 2 decimal places, because it was money. So it's going to cost us $144 for those daffodils. Let's see if I did it right, because I've been known to make mistakes. Yes, D. Yay. So that's it for 1.5. We'll go ahead and work on your assignment. We'll see you next time.